All right, welcome to video number 4. So today we're going to learn about the derivatives of 4 important functions, and after that you'll have some practice problems, and then we're going to learn about a new concept called implicit differentiation. So last time, if you remember, we first learned about limits to infinity, and you learned like this is what e is equal to, right? Pretty straightforward. And then you learn about several derivative rules. And then, so to jog your memory of the chain and product rule and make you understand why the quotient rule isn't so important, I am going to start off by proving the quotient rule with the product and chain rule. So this is the quotient rule. So we have the derivative of f of x over g of x is equal to this. All right, and to prove that, you can think of f of x over g of x as f of x times 1 over g of x. And then now you use the product rule. So the product rule states that first we have the derivative of this function times this function. All right, so that's right over here. And then plus this function times the derivative of this function. All right, and to differentiate 1 over g of x, we use the chain rule. So the inside function is g of x, and the outside function is 1 over x. And first, we find the derivative of 1 over x, which is negative 1 over x squared. And then we replace the x with the inside function, g of x. And then we multiply by the derivative of the inside function, which is g prime of x. All right, and then plugging everything back in, we get this. And then if you simplify, so you can multiply the numerator and the denominator of this term by g of x, and then you get a common denominator, and then you get this, which is the quotient rule. All right, so now these are the 4 derivatives that you're going to be using today. So the derivative of sine of x is cosine of x. The derivative of cosine of x is sine of x. The derivative of ln x is 1 over x. And the derivative of e to the power of x is e to the power of x. So if you want to pause right now and remember these, go ahead. But anyway, now you're going to have several practice problems using these derivatives and the product and chain rule. So you can do as many of these practice problems as you want. If you want to do it, then just pause the video. If you don't, because it's too hard or you just don't want to do it, then you can just watch the solution. But anyway, this is the first practice problem. So pause if you want to give it a try. And when you're ready, keep watching the video for the solution. All right, the answer is you use the chain rule. So the inside function is x squared. The outside function is sine of x. All right, and then so basically the derivative of sine of x is cosine of x, and you replace x with x squared, which is the inside function, and then you multiply the whole thing by the derivative of x squared, which is 2x. All right, this is practice problem number 2. All right, to solve this, you use the product rule. All right, so this is f of x, g of x, f prime of x, g prime of x. So first you want f prime of x times g of x plus f of x times g prime of x. And remember that the derivative of ln x is 1 over x. All right, and then x squared and over x just cancel each other out and leave you with x. And this is the third practice problem. Okay, the answer is, so you use the chain rule. The inside function is e to the power of x. The outside function is cosine of x. All right, and here are the derivatives of these functions. So you do the derivative of cosine of x, which is negative sine of x, and you replace it, the x, with e to the power of x. And then times the derivative of e to the power of x, which is e to the power of x. All right, this is the 4th practice problem. To solve this, the inside function is x cubed and the outside function is e to the power of x. All right, so first you do the derivative of the outside function, which is e to the power of x, and you replace the x with x cubed. Multiply the whole thing by the derivative of x cubed, which is 3x squared. All right, this is the fifth practice problem. To solve this, you first use the product rule. So the derivative of this term, or not this term, this function, times this function, plus this function times the derivative of this function. And you use the chain rule to find the derivatives of these two functions. So for this, the inside function is ln x, the outside function is x squared. So you first find the derivative of x squared, which is 2x, and you replace the x with ln x, and then times the derivative of ln x, which is 1 over x. And to solve this, the inside function is x squared, the outside function is sine of x. So the derivative of sine of x is cosine x. You replace the x with x squared, and then you multiply the whole thing by the derivative of x squared, which is 2x. All right, and then now going back and just plugging everything in, you get that this is the derivative for the function. All right, and this is the sixth and final practice problem. So this one's a little trickier because there are three functions embedded. It's like f of g of h of x. But what you do is you treat f of x as the outside function and g of h of x as the inside function. All right, and you use the chain rule. So first, the derivative of e to the power of x is e to the power of x, and you replace the x with cosine x squared times the derivative of cosine x squared. And then cosine of x squared, the inside function is x squared, the outside function is cosine of x. All right, and then you get that the derivative of this is negative 2 sine of x squared. All right, and then going back and plugging everything in, this is what you get. All right, so these are all of the derivatives that you've learned so far. And now we're going to dive into implicit differentiation, also known as differentiating both sides of an equation, because that's basically what it is. All right, so if you wanted to find the derivative of x to the power of n, how could you do that? Well, you're given that f of x equals x to the power of n, and you're trying to find what f prime of x is equal to. So the first thing that you can do is take the natural log of both sides of this equation. And remember, when you're trying to take the derivative of a function that has an exponent, in this case, we see x to the power of n, we have an exponent. The first step is almost always to take the natural log on both sides, because what it does is, due to the properties of logarithms, you can carry the exponent to the front, and that gets rid of the exponent. Okay, and now you differentiate both sides of the equation. So to differentiate the left side, you use the chain rule. So the inside function is f of x, and the outside function is ln x. All right, so the chain rule, so first the derivative of ln x is 1 over x, and you replace x with the inside function f of x, and then times the derivative of the inside function, and that's f prime of x. And then the right side is pretty straightforward. You have a constant times ln of x, whose derivative is 1 over x. And remember what you're trying to do. You're trying to solve for f prime of x. So the next logical step would be to multiply both sides by f of x. So now you've isolated f prime of x. And then now you know that f of x is x to the power of n. So you plug that in. And then the final answer you'll get is f of prime of x is equal to n x to the power of n minus 1. So this is basically the concept of implicit differentiation. So the important things that you need to remember are, so you're given f of x and you're trying to solve for f prime of x. And to do that, you might differentiate both sides of the equation and remember that the derivative of f of x is f prime of x. All right, now if you want, go ahead and try this problem. Okay, so the answer is, so the first step is to take the natural log on both sides because this is an exponential function, and then you can move the exponent to the front. All right, differentiate both sides of the equation. So we've already seen how we differentiate the left side. And then the right side is just x times a constant. So the derivative of that is just the constant. All right, and then we were here at the last step. So multiply both sides by f of x, and then plug in what f of x is equal to, and you find that the derivative of n to the power of x is equal to ln of n times n to the power of x. All right, and this is the last practice problem for this video. The answer is, like the two problems before, you take the natural log on both sides because it's an exponential function. All right, and you can move the exponent to the front. Okay, and you differentiate both sides of the equation. So we've already seen how you do the left side. And for the right side, you use the product rule. So we have the x times the derivative of ln x, which is 1 over x, plus the derivative of x times ln x. All right, and then we multiply. So first we simplify. X times 1 over x is just 1. And then we multiply both sides by f of x. So we've isolated f prime of x. And we get that the final answer is x to the power of x times 1 plus ln x. All right. And that's basically it for this video. So remember that to differentiate both sides of an equation, you usually use the chain rule. And keep in mind that the derivative of f of x is f prime of x. And your overall goal is to isolate f prime of x. All right, and if you're trying to take the derivative of a function that has an exponent, the first step is almost always to take the natural log on both sides, and then you can use the logarithm properties to carry the exponent to the front. All right, so now that's it for this video. And if you want to know the proofs for the derivatives of the four functions, I'll post it in the description. We've already pretty much covered the proof for e to the power of x, because remember that the derivative of n to the power of x is ln of n times n to the power of x. And if you plug in n equals e, then you get ln of e, which is just 1. So you're left with e to the power of x. But if you want to know the proofs for the derivatives of the three other functions, I'll post that in the description. But anyway, in the next video, we're going to practice more on implicit differentiation, and you'll learn how to use that to differentiate inverse functions. And after that, we're going to learn about a new concept called L'Hopital's rule, which can be used for evaluating limits. But anyway, that's it for this video. So I'll see you all in video number 5. Peace.